Okay, I'm getting delirious on calculus. Or what class is this? See, I'm getting delirious. Credit card for the population of U.S. household. Credit card debt. Credit card balances of a sample of 70 households. So I already feel like, I know what we need to do here. We're going to do, you know what? I'm just going to get rid of that one. And I'm going to come up here and grab like this one because I like that layout and bring it down here. And that looks like, where's my sample, man? Oh, that's the calculation. There's my sample. Now I'm going to put this here, and I'm going to grab this, boom, and I'm going to get rid of that, boom, and I'm going to do that, and then I'm going to copy this and do it here, and then I'm going to drag it out, and then I'm going to hit my Windows key, right arrow, and then select this one, and then I'm going to go here, and now I've got left side by side. So, example, we have credit card balances with a sample of 70 houses. So our sample size is 70. And let's just delete all this stuff so we don't leave anything in there. So our sample size is 70. And our sample mean provided a mean credit card debt of 9312. 9312 is our sample mean. And then our population standard deviation is, we don't know. And then our sample standard deviation is going to be with a sample standard deviation of 4007. Cool. And let's do a 95% confidence level. 95% interval estimate of the mean credit card debt for the population of U.S. households. We'll assume the population is normally distributed. So we're assuming the population is normally distributed, but our degrees of freedom are going to be equal to n minus 1, and so our n is 70, so we'll do 70 minus 1, and that's going to be equal to 69 degrees of freedom. And our tail is going to be, so our alpha divided by 2, so 5%, confidence level is 95%. That means that our, confidence level, and then we have our level of significance is alpha. So our level of significance will be 5%. And my question is do I do this for both tails, 95%, and I divide by 2? So I take my alpha and divide by 2 to get my t, or do I do just 5%? In that top tail. And I'm going to say it's divided by 2. I'm not sure that's accurate. So alpha divided by 2 is equal to 0.05 divided by 2 is equal to 0.25, right? And 0.05, and that should be divided by 2. Divided by 2 is equal to 0.025, which is 2.5%. So 2.5%, so we have our t table here, and I'll just make this a little bit smaller so we can see it. And if this is like 0.025, and we have 69 degrees of freedom, 69, we have 70, but we don't have a 69. So we're like somewhere between 2 and 1.994, right, between those two values there, and really close to 1.994. And that's the 95% confidence level. So we did that right? So note t of infinity alpha divided by 2 is equal to z alpha divided by 2 in our notation. So that was correct. So we've got that. And that means that our t-score, or t-value is going to be equal to, and that's like z, which is like this many standard deviations. I'm just going to go with like 1.994 to 2. That's really close. I'm just going to go with 1.995. We'll say it's a little bit closer to the 2.0, right? We're just like at 69, not quite 70, so we're moving a little bit closer to 2.0. All right, so that's my t-value. Those are the little notes I put together. So now how do we calculate the interval estimate? Confidence level, so our t is t. We calculated that already, is 1.995. And the margin of error is going to be 1.995 4.95, and it's going to be multiplied by margin of error. And so we come back over here and look at our t stuff and look for our margin of error with our t stuff. And so I'm looking for my margin of error with my t stuff. So there it is. So it's t times my sample standard deviation divided by the square root of n. So my sample standard deviation is 4007 divided by, and it's the square root of n, so 70 square root. I'm going to get my calculator, calc, and we're going to do 70 and hit the square root. That's going to be that number. I don't know if I could copy this. And let's call it 367. Copy that. 8.367. And did it do it? 8.367. And when I calculate this, right, I get that number. And that number times 1.995. So we could put all that in, actually. We could just do the whole thing. Boom, gives us 955.42. Okay, rounding. So we're going to do 955.42. And the confidence interval, aka the interval estimate, is going to be our sample mean, which is 9312. 9312 plus or minus 955.42, which means if we do this, I'm just going to bring this up here, and we'll do minus, and then we'll do that once more, and we'll do plus. We've got that number. Whoop. That number all the way up to this number. Whoop. So our confidence interval, aka our interval estimate, with 95% confidence based upon our sample that we collected with 70 elements, our sample size of 70. We got a sample mean of 9312, which that sample mean could have been different if we had different elements in our sample. But based upon the sample standard deviation, we have 95% confidence that the population mean is going to be between $8,356 and $10,267. That seems like a pretty wide range. Let's see what the book says, okay? So here's the problem. Here are our calculations, and we could get rid of this side over here. And, oh, and I do need to change this one right here. So I'm going to take this, kaboom, come over here and change that, swap that out, kaboom, kaboom, and drag this one over here and put it right there. Okay, like that. So we came up with that range, and I guess it would be good if actually, here, let's just copy this, and we'll keep this over here so we could keep looking at that. Enter, and come on, go big. Now go that way. There we go, that's what I'm looking for. All right, and so here they got a 1.995. So that was our guess, and that was actually right on. We didn't have 69, maybe in the book it does, but we got the degrees of freedom right, and we got this alpha and alpha divided by 2 right at 95% confidence. And then we have 9312 plus or minus 955, and that's pretty much what we got. We did a little bit more to the pennies. And so we are 95% confident that the mean credit card debt for the population, right? Why isn't that highlighting? Highlight for me. Border color. I don't want border color. I want highlighting. They look very similar. That the mean credit card debt for the population. So population, come on in.
Yeah.
All right, I'll be there in a minute. Population mean, and households is between those values, and that's what we got, 8356, 10267. Wow, amazing. All right, let's just finish this slide out, and then I'm going to call it good and go eat dinner. Usually a sample size of n greater than 30 is adequate when using the expression da 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 to develop an interval estimate of a population mean. If the population distribution is highly skewed or contains outliers, you need more in your sample size. And this is similar to what we've already read and learned about. We're doing great. You're doing great. We got like 3 more colors. We got hot pink, we got yellow, and we got orange. And that's going to deal with, what is this? Sample size of an interval. So like, can you calculate things backwards and figure out a sample size to get the statistic you want? And then we're going to do population proportion, and we're going to do sample size for population proportion. So we'll see proportion. We've seen mean, then we'll see proportion. These are interval estimates. These are interval estimates, okay? All right, I'm hoping you're getting a sense of this. When it starts to, you work a couple problems, it starts to click. I would go to ChatGPT, work one of these problems, and work a couple, have it explain it, and it'll start making more sense. See you next time. See you in the next video. See you next time.